Hi there, we're going to be taking a look at systems of linear equations over the next week or so. This is going to be our next unit we're looking into, and we've got a few different ways that we're going to talk about, and I'm going to talk about the first way today. So first off, a system of linear equations is finding where two lines cross. We've got two lines, and we are simply looking for where they cross. We're given, we're going to find three different ways of solving this. Most of the time you'll get to pick which way you're choosing from, but until we learn all of them, we're going to have to use whichever one we know. The first one that we're going to learn about is graphing. This is where we graph each of our lines and we simply look. We see, okay, they cross right here where the two lines intersect. We also have substitution, which is an algebraic way of solving it. That means we're going to be plugging things into one equation and the other. We also have the elimination method, which is a little bit different, but it is still another algebraic way of solving a system of linear equations. Unlike some of the other problems, we may have a different number of solutions here. The most common type of solution we have is when we have intersecting lines. That means there's one solution. For example, over here, if I draw it out, we've got one line going one direction, one line going another direction. They cross at one point, and that's all there is to it. There's just one solution because they only cross at one point. If we have two lines that are parallel, that means the lines never intersect. That means they're going in the same direction. They never get closer together. They never get farther apart. And since they don't cross, we have zero solutions. We will encounter this when we do not have any solutions at all. We also have a situation which is called collinear. That means they're the same line. It looks like we only have one line here, but if we draw one line right here and then we draw another line on top of it, we can't actually tell one line from the other because they're the same line. And when this happens, we have infinite solutions. So sometimes we'll have one solution. This will be most of the time. Sometimes we'll have zero solutions when our lines don't cross. And sometimes we'll have infinite solutions when the two lines are right on top of each other. Let's take a look at an example. I've got y equals 3x minus 2 and y equals negative 2x plus 8. Both of these equations are already in slope-intercept form, so that means we can go ahead and just start by graphing. At this point, if you are not remembering how to graph an equation in slope-intercept form, you need to pause this video, go back, and take a look at the video that we had about graphing. If we're graphing this first equation right here, we want to start with the y-intercept, so we're going to go down 2 spaces and mark our point. Then since our slope is positive 3, that means we've got a rise of 3, and we're going to the right once. So we're going to go up 3 spaces to the right once. We mark our point, and we're going to do this again. We're going to go up 3 more spaces and to the right one more time. And you know what? Normally I only require you to have 3 points, but I'm going to do one more time just to make this a little more obvious. So I've got my points here. I'm going to draw a line connecting them. So I've got my line now. So I want to graph my second line now, and my y-intercept is 8, so I'm going to go up 8 spaces from the center. And this time my slope is negative 2. So that means I'm going to go down 2 spaces and over 1, and then down 2 spaces again and over 1. So I've got a few points now, and I want to connect them. And we see our two lines intersect, and this point right here is going to be our solution. So I'm going to count over and I'm going to see that this is the point 2, 4. So this is the point 2, 4. And this right here is our solution. We need both the x and the y to make the point.